In this problem, there are n segments, and we are given the leftmost point and the rightmost point of these segments. And we want to find the least number of segments we have to delete to make something called a good set. And a good set is basically a set of k segments such that we can pick one segment and that within the set, and that segment intersects every other segment in that set. Okay, so that sounds really confusing. So let's just say this is my first segment, this is my second segment, and then finally this is my third segment. If we pick this segment, since this segment intersects with every other segment, which is this one and this one, oops, that means that this is a good set. But for example, if we also added something like this, then this would not be a good segment because if we pick this segment, there's no way we intersect this. Same for this and this. And if you pick this segment, then there's no way we intersect any of these segments. So therefore, this is not a good set. So okay, actually, when does this ever occur? So let's say we were given these four segments, right? So we're trying to find out the minimum number of segments we have to delete such that the remaining segments form a good set. And clearly the answer here is 1. So if you just take away this segment, we have a good set. So how do we do this? So when do we not form a good set? Set, right? Yeah. So let's go through all the segments and let's say that it's the main segment. It's the segment that intersects with all the other segments in this final set. So let's assume that this is our big segment, right? This is our main segment. So this intersects with this and this. So therefore, the only segment that this main segment does not intersect with would be this last one out here. So therefore, we try to find that. So it doesn't intersect if the rightmost of our big segment is smaller than the leftmost of any segment, or if the leftmost of the segment is bigger than any rightmost. So that would be, for example, oops, if I could just make this a bit shorter. So if we have one more segment here, in this case, the leftmost of our main segment is bigger than the rightmost of this segment. So therefore, this will not be counted in the good set if this was the main segment. So essentially, we have to go through all the segments we're given, and then we assume, say, hey, let's assume this is the main segment. So then we have to find out the number of segments that do not intersect the segment, and we do that by seeing the number of segments such that the right value is less than our main segment's left value, and the or such that the left value of a segment is bigger than the right value of our main segment. And we can do this in log n in C++ using functions such as upper bound. So how do we do this? So I think we have t, yeah, in t, c in t, while t minus minus, do that. So next we're given n, and then vector n. So left and right. So we're given, so we need some order, right? So let's just go init left of size n, and then init right of size n as well. And then for n, we just see in init l and init r, yeah, I. Okay, and then so these two lists preserve the order, so we know which L is linked to which R. So it's 1, 4, 2, 3, 3, 4. So now what we have to do is to use upper bound and lower bound to make them in log time, we have to sort L and R, but we also want to know the order, right? 1, 4. So let's just create two other vectors. Just call them L and make that init L, and R and make that init R. And now we just sort all L and sort all R. So this just sorts the list L and R, but keeps init L and init R the same. So this way we preserve the order like 1, 4, 2, 3, 3, 4, and here we just sort all the lefts and all the rights. So now that we have that, the maximum answer we could have would be n minus minute. So the worst case scenario, we only have one segment in the good set. So our answer would be n minus 1 because we'd have to delete every other segment. So then for n, let's find the best case scenario. So int to delete would be the. So let's look at the case of this where the r is less than our main segment L. So that would be lower bound of R. I'm trying to find init Li. Then we want again, and then 2 del plus equivalent to n minus. What would this be? This would be lower bound or upper? This would be upper bound of all R init R I, then minus L dot begin equals, we want the minimum, right? The minimum of and then answer. I think that should be it. It's just a simple sorting and then upper bound, lower bound question. Yeah. Yeah, so while I was doing the contest, I could not solve this question. But then I think Neil streamed after the contest, and he went over this, and this is a very, very straightforward thing. I just didn't think to do any of the sorting or anything like that. Yeah, but yeah, I think this should work because if my memory serves me, yeah. So voila.